Hello folks, welcome back to Java Object Oriented Programming. Now we are discussing about another important feature, that is inheritance. The basic definition of inheritance is defining new classes using existing classes. These new classes are going to use the existing features and extend the features of existing classes. For example, there is a class called A with only one member method. In this method, there is no much business logic is there, just simply displaying the significancy of the particular method. Now, I have another class called B. This B class again is going to have only one method. This class B is also have one method. That method is again displaying the significancy of the method. Now in this definition of class B have a keyword that is extends. The meaning of extends is the class B, you are defining that class B is extending the features of class A. In this context, class B is called the subclass and class A is the superclass. If you want to draw exactly these classes in UML diagram, that UML appears like this. Now let us try to implement exactly these things in a simple demonstration. Now let me create a simple project. This Java project name is inheritance examples, and remaining all other attributes are same as it is. Just I can go ahead with the finish. I have a project here that is inheritance examples. Now in this project I will create a class called A. This class should be a member of the package com.ignite.beans. Now in this class I'm going to have only one method that already we have discussed earlier. This is method 1. Now exactly the same way I'll create another class. Now this class is the subclass. The class name should be B. Here the superclass, at this place you mention the superclass name and then click finish. Otherwise simply leave it as it is, java.lang.object. You leave it as it is and go to finish. Here you may give extends A. Both are perfectly accepted. One is by the time of creation of the class you can mention the superclass name. If you forget the superclass name mentioning during the class creation, you can give that superclass name here once after the class has created, like this with extends keyword. Again, even this subclass also going to have one method, that is method 2. Okay, just have a look on superclass, that is class A, member method method 1, and subclass class B, member method 2. Now we'll go to application. This application should be member of another package called app, and then the class name should be use AB. Any name is suitable, but here I am giving the purpose why I am defining this class. I am using as the class name, and make sure this class is going to have the main method. Click on finish button. Now here let us create an object of superclass A equals to new A, and subclass object that is referred by B. Okay, now let us call member methods with both A and B. With A superclass reference you can call only superclass method, whereas with subclass reference you can call both the superclass method as well as the subclass method. So this is the way how we can use inheritance. Now we'll display a simple message just above these two, method 1 with superclass and method 1 2 with subclass references. This is with object of superclass. The similar way here says out with object of subclass. So subclass object is subclass is B and the superclass is A. And we'll add an empty line between these two outputs. Now let us execute the program and see the output. Run as Java application. Now you can see here with object of superclass, what you can call only method 1, whereas with object of subclass class B, did you notice you can call both of the superclass as well as subclass methods. So this is actually we are discussing in inheritance. The class B uses both superclass methods as well as subclass own methods. Here, as and when you write extends A, the superclass members directly came to here in the subclass. Now, with object of subclass, you can call superclass members as well as own members. Superclass members means inherited members. With a subclass reference, you can call superclass members as well as its own members. That means inherited members and own members. Now, how exactly this inheritance feature is used in production? What exactly the purpose of inheritance in production? Let us try to understand. Suppose I am developing a software application for a production company where there are two kinds of employees. They are salaried employees. For salaried employees, my client is going to capture ID, name, email, and the basic pay of the employee. And another kind of employees my client have, they are contract employees. About contract employees, ID, name, email, and pay per hour, these are the data my client is going to capture. But in this scenario, if I define classes exactly like this, if you closely observe, your ID, name, email, these three members are getting repeated in both of the classes. But after all, repetition, will it be really a problem? Not necessary to be. If we may copy paste these properties, after all, copy pasting will never be a problem. But if you observe closely, if you think in futuristic way, suppose if the client wanted to change their mind to store first name and last name instead of simple name here, first name and last name, these two places we need to update the code. Suppose if the client wanted to add blood group, then in the both of the classes we need to update. So this is really a challenge. After all, a small updation demands repetition of modifications. This causes low maintainability. In order to improve maintainability, we suggest this kind of inheritance hierarchy. Define a superclass called employee and capture all of the commonly or repeatedly occurring attributes: ID, name, email. Did you remember? These three members are repeated in both the salaried employee as well as the contract employee. Now, you make your salaried employee as a subclass of employee, and contract employee is also subclass of employee. As a result of making this salaried employee and contract employee as subclasses of employee, what happened? ID, name, email, and then related members methods has inherited to both the salaried employee and contract employee, and the specific members, basic pay and pay per hour, are members of the subclass or own members of the subclass. As a result of this kind of inheritance hierarchy, let us think about the previous scenarios. If my client wanted to implement first name and last name, here in the superclass only we need to modify. Now, if any blood group kind of common variables or common attributes my client wanted, simply we can define in the superclass employee. So this is the advantage of inheritance hierarchy. Here the thumb rule is extract the common features across multiple classes and define in a separate class, and define specific members in the subclasses. So here that is the thumb rule for this inheritance hierarchy. This inheritance we can present in this form of UML diagram. Did you notice here? ID, name, email, these three are members of the superclass, and salaried employee is extending the employee and having its own member basic pay. In the same way, the contract employee pay per hour. Now, if I instantiate this inheritance hierarchy, what will happen? How the objects will appear? Let us try to understand. I'm creating an object of employee, superclass object, referred with E, and as a result of writing like this in a program, it creates an object of superclass and referred with a reference variable of employee class, that is E. So this is the result of this simple instantiating the superclass. Now, if I create an object of subclass salaried employee, it appears like this: an object of subclass new salaried employee, inside of salaried employee basic pay setter getters, and then an object of its superclass, that is employee class object, that is inside of the salaried employee class and referred with its corresponding variable S, that is salaried employee class reference variable. Again, I am creating another object of contract employee C equals new contract employee. As the result of executing this line, new contract employee, an instance of contract employee will be created in the memory. It is going to have a pay per hour member variable of its own plus setter getters and another instance of its superclass, that is employee object, again referred that with the reference variable C. This is the way objects are created in the memory. Now, if I want, I can store the ID values of every employee. Employee E dot set ID of 101 means what happened here? Employee object, this is E, referred with E. So here in this object, employee class object, that is superclass object, is going to have 101 as ID. Now I want to store 201 as ID of salaried employee. So as a result of executing this statement, the ID value of the salaried employee becomes 201. In the similar way, contract employee, I am going to have 301 as ID, that 301 came here. Now, here the major intention behind this pictorial presentation of these objects is the superclass object containing inside of the salaried employee don't have any influence of the superclass object contained, that is inside of the contract employee. So these two subclasses will have its own copy of its superclass. For example, let us consider an inheritance hierarchy. Class A is a superclass, B is its subclass, C is its subclass, D is its subclass. A, B, C, D, let us say 4 generations of classes. Now I have instantiated the class D, that is of the 4th generation class. Inside of class D object, its super C object is there. Inside of C, its super class B object. Again, inside of B, class A object is there. In this way, objects are created. Now, let us see this inheritance hierarchy in code. First, I'll define a class called employee here in the same package, beans, new class employee. And this employee class should have ID, name and email. String name and another string email. Along with these member variables, it should have all setters getters. This is all about my superclass. Now define the subclasses. New class salaried employee. This salaried employee should be the subclass of employee. Now com.ignite.beans.employee. Finish. Here the superclass is going to have all common features or common qualities or common attributes. In the subclass, specific features we are going to define. When you are traversing towards the superclass, you find all common qualities. When you are traversing towards the subclass, you find all specific features that we are going to show in code. Since this is salaried employee, one double variable, that is uh, basic pay. And now setter getters related to this basic pay. So setter method and getter method for this basic pay. Again, we need to define one more subclass of the same employee, that is contract employee. Here I forgot to mention employee superclass, forgot, and directly straight away I clicked the finish button. Now what can I do? Nothing to worry. Here you can mention extends, partially you type and press control space and then type employee. Again here also control space you use, so automatically the class name will appear there. Now here specific member variable of this contract employee is double pay per hour. Now necessary setter getters to this pay per hour. So this is all about my inheritance hierarchy. Employee, that is a superclass with ID, name, email. Salaried employee, that is with the basic pay. Contract employee, that is with the pay per hour. Now in the application, let us create a class called use employee underscore 01 with the main method. Then click on finish button. Here let us write, let us instantiate all these three different employees. Employee E equals to new employee of, then salaried employee S equals to new salaried employee, and then contract employee C equals to new contract employee. Finished. I have three objects with me. They are E, S and C respectively, employee, salaried and contract employee. Now E dot set ID 101 and S, that is the salaried employee, dot set ID 201, then C contract employee dot set ID, that is 301. Now let us try to retrieve them and display. How we can retrieve? E dot get ID. Now let us pass this ID value to system dot out dot println. ID of employee object. Now sys out ID of salaried employee object, that is S dot get ID. Now another display message, ID of contract employee object plus C dot get ID. Finished. Now we'll execute this and we'll see the output. See here, employee object's ID is 101, salaried employee object ID is 201, contract employee ID is 301. Can you find this exactly same as the presentation here? So this way objects are created in the memory. Few more features related to inheritance we need to observe, that we'll see in continuation of the videos. Thank you for watching. So we'll discuss a few more object-oriented programming features in the continuation series of videos, and thank you for watching.